We've seen that voltage is the amount of energy that each coulomb of charge has. So 1 volt is 1 joule of energy per coulomb of charge, 2 volts is 2 joules per coulomb, and so on. In our animation, we've said that red energy circles this size represent 6 joules. So we can see what happens to the voltage or potential as we go around the circuit. So 6 volts, 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 5, 4, 3, 2, 1 volt, 0 volts, 0 volts, 0 volts, 0 volts, 0 volts. So the difference in potential, or potential difference, between 2 points is just the voltage difference between those 2 points. So this is at 6 volts, this is at 0 volts, so the potential difference between this point and this point is 6 minus 0, which is 6 volts. This point is also at 6 volts, and this point here is at 0 volts, so the potential difference between this point and this point is also 6 volts. This point here is at about 3 volts, a potential of 3 volts, so the potential difference between this point and this point is 6 minus 3, which is 3 volts. That's a difference between 6 and 3. The potential here is about 4 volts, so the potential difference between this point and this point is the difference between 6 and 4, which is 2. The difference between this point and this point is the difference between 4 volts and 0 volts, which is 4 volts. A voltmeter can only measure potential difference. It can't measure potential at a point. We can only imagine, using, for example, our animation, what the potential at a point looks like. So to measure potential difference, we connect the voltmeter either side of the component that we're trying to measure the PD across. And we call this connecting the voltmeter in parallel. So the PD across the battery is 6 volts, the difference between 6 and 0. The PD across the bulb is 6 volts. It's the difference between 6 and 0. What do you think the PD across the wire is between here and here? Well, this is 6 volts, and this is also 6 volts. So the potential difference between 6 and 6 is 0. So there we go, it measures 0 volts. Equally, the potential difference between, for example, this point and this point is the difference between 0 volts and 0 volts, and the difference between 0 and 0 is 0. There we go, so that's 0 volts as well. In our simulations, we can measure the potential at different points in the bulb filament, but obviously we can't do this in real life very easily. So for example, we could measure the PD between, for example, this point and this middle point in the bulb. There we go, about 3 volts. We could measure the PD between this point and that point in the bulb. There we go, 3 volts. You just need to bear in mind there are these readings that, they do have rounding errors, so you would have expected that to be 3 and 3. Voltmeters are designed so that they don't change the voltage they're trying to measure very much. And for that reason, they have a very high resistance, and that means that very little current actually flows through them. And in an ideal voltmeter, like we have in our animations, we imagine that 0 current actually flows through the voltmeter.